Good afternoon. I'm from Ukraine. My name is YURIY DUBOVENKO and I would like to present to you my notes on the use of social networks as a prediction market tool for improving the practice of evaluating scientific research. Scientometrics is a qualitative study of science, communication in science and science policy, according to Hess. This field has evolved over time from studying indices for improving information retrieval from peer-reviewed scientific publications, bibliometric analysis of science, to covering other types of documents and information sources relating to science, datasets, web pages, and social media. Scientometric indicators complement and contribute to efforts to standardize, collect, report, and analyze a wide range of science, technology, and innovation activities by providing evidence on science and technology outcomes. Its citations matrix is divided into four main levels: article level matrix, journal level matrix, author level matrix, and alt matrix. It is convenient to apply automated statistical metrics to scientific outputs in order to evaluate the productivity of scientists and ways of economic support of the scientific industry. Scientometric indicators were evolved from the start of introduction into scientific circulations, and here are H index, G index, HG index, E index, A index, R index, M index, etc. When comparing researchers in different scientific fields, it needs to correct for differences between fields in publications, collaboration, and citation practices. Field normalized indicators make corrections, but the design of these indicators is a challenge. Ukrainian scientists also got involved in this process, developing a fractional Stauber index, which allows ranking the contributions of authors with the same Hirsch indices. A universal citation impact measure extends Hirsch index by rescaling citation counts and research and publications, but its computation requires the extension citation impact data and statistics for every discipline and year. The social crowdsourcing to scolarometer evaluate the universality of the citation impact matrix, IDEST the field normalizes Hirsch index. Automated citation indexing allows millions of citations to be analyzed for large-scale patterns, but first, scholars engage in ethically questionable behavior to inflate the number of article citations, and second, all scientific metrics are bound to be abused. When the economy feature is an indicator, it ceases to function as that indicator because people start to game out it. Therefore, next slide clearly suggests how you can inexpensively increase your Hirsch index, for example. When demand arises for quick metrics in the modern digital world, startups are emerging quite quickly to automate the evaluation of academic achievement metrics. You can see one of them in the next slide called scolarometer. Another alternative to proposition of giants of markets is a tool for scientific metrics provided by the Organization for Economic Cooperation and Development. As you can see on the next slide, it is possible to estimate the total number of scientific publications by countries in a given branch, for example in earth sciences. Here, The number of Ukrainian publications is 1.5 order of magnitude behind the world industry leaders. The prediction markers predict the outcomes of the replications well and outperform a survey of market participants' individual forecasts. They are a promising tool to assess the reproducibility of published scientific results. The prediction markers allows estimating probabilities for the hypothesis being true at different testing stages, which provide information regarding the temporal dynamics of scientific discovery. And here you can see centralized prediction markers. Companies such as Hypermont, Predict It, Best Fair, Good Judgment, Metaculus, as well as decentralized companies such as Gesser, Gnosis, Augur, etc. And what about crowdsourcing scientific prediction marketing? Some outcomes you should track in psychology investigations aimed to overcome the replication crisis. It means that research that can't be replicated hinder discoveries. Could an artificial intelligence-powered tool change the incentives to benefit scientists? Scientific papers every year increase, but scientific knowledge is not. Any scientific results may not be reliable. Falsification, a strong hypothesis, along with methods that test and refute this hypothesis, should be used by researchers. Testing and resulting hypotheses through a team science framework allows addressing the heterogeneity in samples and or methods that make so many published findings tentative. It would be fantastic if test whether a prediction marker could be added to the review process, not replacing the 3 to 4 reviewers who carefully read the paper, but as an addition and to see how much that could improve the review. It is believed that the combination of multiple individual evaluation compensates for the subjective biases of experts and turn into the wisdom of crowd, allowing to derive a more accurate decision. This phenomenon refers to the behavioral economics, and its essence is properly described in the note of Ryabova. Well, but if we need to collect some statistics for scientific metrics, then how do we measure the contribution of individual fellows of scientific groups? In this occasion, the global player ОЦІНЮВАННЯ has already offered its own set of contributions to scientific output, allowing them to be marked by the participants of the scientific process themselves. Now, we just came to our own problem, namely the nuances of distribution of contribution within group and their fixation in scientific databases. Therefore, we set the following weekly formalized problem in the form of a survey. The founder researcher developed a theory. Based on it, he solved an important scientific problem and published a unique article, while a group of disciples followers apply the results of founder in small applied directions and write articles referring to each other and to founder researcher who himself no longer writes. Therefore, founder researchers has indexed Hirsch index 1 and its followers gained Hirsch index much more. Who in this scientific group will have greater scientific authority? The initial condition of the problem are as follows. The author of the idea doesn't claim co-authorship, and B, it is not necessary for him to be the chief. A question arises here. Is it appropriate to include co-authors even when he or she did not write anything in the text? The discussion should a rather wide range of opinions, but allowed to clarify and enrich the wording. In the end, the main provisions came down to the following considerations. Authors of article are not identical to persons who wrote the text of the article. Authorship equals idea plus measurements plus other impacts. If the results of measurements are in the text, their performers are true co-authors. In the natural sciences, gaining results is often the main thing, and their description is secondary. If the disciple follows contains scientific activity, he should publish. For the decision making, though unfunding the projects or tenure, Hirsch index is rather true. But investors do not need the Hirsch index. A venture entrepreneur will choose to support founder researcher who came up with the idea himself and not someone who only used the idea. There are resources that consider, in addition to articles, also patents, preprints, software, and all about without human input, as the Excel.com resource. Founder researcher deserve preferences, but with reservation, not disciple followers. Real authority is measured not only by Hirsch index, but other formal evaluation techniques, not just Hirsch index, could have detected this feature. Among them are nominational references, they could be, for example, Crowley method, Jacobson organ, Newton formulae, Volt unit, Pearson law, Voronoi theorem, etc. But if external management arises and resources could be evaluated, how could you control why a founder researcher has such preferences? If founder researcher is taken as co-authors and his Hirsch index will increase, this may conflict with ethics integrity. Hirsch index is a measurement tool and has a purpose and sensitivity area. Though the tool was not used for its purpose in this case. Formal approaches are an inevitable evil in the context of impersonalistic control mechanism. There are many alternatives to Hirsch index, and new ones are emerging now. Among them were proposed anti-Hirsch index IDEST, number of publications that borrowed your ideas, data or material, but didn't cite your paper properly. The indexes are an evaluation tool and not the characteristic and the mandatory criterion for decision making. Decision making in complex hierarchies, which are scientific teams, requires explicit or clear criteria. Temptation of simple decision is almost irresistible. But collective discussion produced more qualified opinions that the authors could have achieved alone. And this joint contribution is a valuable practice for evaluating the problem of scientometrics. The practical value of this quiz presented to you is a completed formulation of the problem and clarification of its boundaries. The benefit of using collective discussion for the foundation of problem reviews, writing the history of science, and the development of scientometrics is indisputable. And all we can summarize all this conclusion presented above with the help of the following quote of Bartling's opening sign, quote, "Modern information and communication technologies have changed scientific research, exchange and discussion of ideas in social networks for scientists, new media for collaboration, new publication formats, etc. The criteria and spreading of knowledge are becoming more transparent and accessible. Research processes will change even more in coming years due to the tools and visions that drive the current scientific revolution, often called open sciences. Thank you for attention.